Okay, for number one, it says solve by using determinants. And certainly we did go through it in this section over here. One thing I was surprised to learn that Wells did not refer to this as Cramer's rule. Nowadays, is I think universally known as Cramer's rule. It's very methodical. It's easy to write down, but like most things, it may be easy to write down. It's the determinants that are difficult to compute. But let me go through this. I'm not going to actually do the computation. I want to point out what D is in the problem. D is the matrix of the coefficients of the variables. So 1, 3, 4, 2, 5, 1, 3, 1, 2. Again, 1, 3, 4, 2, 5, 1, 3, 1, 2. And DZ is really going to be the same matrix, except now the column of Z's is going to have the constants in them. And we derived the formula by taking some examples of a 2 by 2. And again, you can extend it, and certainly is the general pattern to it, all right? So that's DZ. What's DY? Really the same thing. It looks the same. The column here is going to have the constants. That's the Y column. Then the X column would have the constants in it. You compute the determinants. You get some numbers over here. Now, granted, this is not a bad technique. A lot of teachers say this is the best technique to solve a linear system. I disagree with them. If I were solving this thing, I would not go to Cramer's rule. However, if I were programming this, I would definitely use Cramer's rule because it's very methodical. It really depends on just computing a determinant. But if I were doing this by hand, again, what I would be doing, I would do this. I would use augmented matrix. And there's a point to it, an augmented matrix. It makes more sense to me. And it's easier for me to do. And what would I do? I try to get a bunch of, well, you know, the fact is I would try to go to reduced row echelon form. But sometimes I really can't do that. I just go in stages and do it. For example, the first thing I would probably do, and I'm not going to finish it out. We've done many of these before. Minus 3 row 1 plus row 2, give it to row 2. I would probably do minus 4 row 1s plus row 3, give it to row 3. And then I'd have a 2 by 2, and then I'd do one more step and I'd get there. It's really that simple, right? It's really that simple. The problem with this, with Cramer's rule, is the computation of determinants. However, I do know why it's popular. If you're good at computing determinants quickly, it goes quickly. It really does. It does go quickly. Whereas the augmented matrix, it's work. It goes quickly, but it is work, all right? It is work. Both are work. Determinants for me are something I don't enjoy doing, though. Thank you for paying attention, though. Anyway, the answers are listed here for you. I'm not really going through that. Kind of tedious and boring, I think, but that's the answer. Can that be verified? Of course it can be verified. Thank you for paying attention.